All right, so I was told that uh, there wasn't any sound on the last one, so that's what I get for putting this up too quickly. So I'm just going to do this again. So let's go over section 5 to the end. Okay, so section 5 has to do with categorical variables. So let's get started on that. So categorical variable is just something that is going to describe what something is. Okay, so whether or not someone's a female or not, whether or not something is a Toyota or not. Okay, so in the homework by now, you've seen that we have this variable called prog. Okay, and that's this prog variable is several different programs. Okay, by putting this I in front of it, basically it's going to give us a dummy variable for each of the things that's in that program. Okay. So what is a dummy variable? A dummy variable is, again, it's just if we have some variable that is one if and only if it has some characteristic. Okay, so like female, for example, or if it's a Toyota or not. And basically, what the effect of this dummy variable is, in the most basic sense, is it's an intercept shifter. So let me show you what that means. So let's say, so this graph down here. This is from the book. I use slightly different notation than this example, but I'll write it down here with our usual notation. All right, so let's say we're interested in wage, the effects of wage, and we've got our beta 0, we've got our beta 1, and we've got education. Okay, so we say education affects wage. Okay, now we've got this beta 2, which is attached to this female. Okay, so we put female in the model. So this female is one if and only if the individual is a female. So basically what we can do here is we can say, well, this is just going to shift the intercept, whether or not we're talking about a male or female. I'll show you why. Again, this is a dummy variable, so if female is equal to 0, in other words, if we're talking about a male, then this whole bit is going to go away. Okay, and then we're stuck with this beta 0 plus beta 1 times education. So we could say that maybe that's what this line is right here. Okay, and again, they use a little bit different notation. They're saying the same thing. Okay, now what if we're interested in the effect of education on wage for females? Well, if females are what we're interested in, we're looking at just females, then this females, that's going to equal 1. And if that equals 1, then this whole term here is just equal to beta 2. So beta 2 times 1 is just beta 2. So what we've got is beta 0 plus beta 2. I'm just going to collect the like terms here. These are just constants. And we're going to have that plus beta 1 times education. And that's going to equal wage. Wage equals. Okay. Now, again, they're using different notation here, but what this is saying is they're assuming that this beta 2, the coefficient on female, that is going to be negative. Okay, and that makes some sense. We're always talking in economics about a wage gap. Females are paid less for the same job, and one of the most interesting things we try to do in economics, we try to figure out why is that the case. Just assuming that this is the case, as we see a lot of the time, then we would see that this beta 0 plus beta 2, since beta 2 is going to be negative, then our intercept's going to shift down. Okay, so whereas this line starting right here, this right here is our beta 0, and this line right here is going to start at beta 0 plus beta 2. Okay, so this is the second one here. This is going to be our regression line for just females. Okay, so that's basically how a dummy variable works when it's on its own. At least it's an intercept shifter. Okay, so we also talked about nonlinear relationships. Okay, so why would we do this? Maybe we've got our relationship isn't linear. The real relationship isn't linear. Maybe it's in some sort of situation like this. Okay, we see where we've got this e in here. E is the inverse function of natural log. So if we use natural log, we can actually kind of break this stuff down into something that our regression can actually calculate. But the problem with doing a transformation like that, if you want to call it a problem, and an issue to be knowledgeable about would probably be a better way of saying that, is that our interpretation is going to change because of that. Okay, and we're just going to look at this table, and this table is going to tell us exactly how the interpretations would change. This first bit here, this level, that's what we've been doing this whole time. Okay, so it changes by 1 unit, x changes by 1 unit, and the change in y is beta 1. Okay, another one of interest is this log one. This is one where our interpretation is of elasticity. Okay, we remember elasticity from our principles of microclass. So basically, we're seeing if as x changes by 1%, beta 1 is representing the percent change in y. Okay, so those are the two more interesting ones, I guess. This one we did up here was we did basically a log and then level design. Okay, so we did this one. Okay, so that's when we've got our log variable is the y, but our x is not logged, it's level. Okay, so we would say here, well, as x changes by 1 unit, then y is going to change by 100 times beta 1. Okay, in terms of percent. Okay, and the other way around, so we got this dependent variable y, and our independent variable is log of x. Then our beta 1 interpretation is that, well, as x increases by 1%, then y is going to change by beta 1 over 100%. Or excuse me, beta 1 over 100. So now let's talk about interactions. So we may have it. So let's start with this original equation here. We're interested in wage, and we've got education. We're saying education affects wage. We're saying whether or not you're female or male, that affects wage. We're saying the number of children that you have affects wage. But if we want to get more specific, maybe we could say that, well, what if the effect of having children on wage varies based on whether or not you're female or not? Okay, so if we wanted to ask that question, what we could do is we could interact female and children together. Interact meaning we're going to multiply them by each other. And notice that I also included in this second regression here, female and children. So generally that's what we do. We always include both the interaction and the individual bits of the interaction. Okay, so how do we interpret that? We'll get to that in the next page. Okay, so let's not get ahead of ourselves. Let's look at what we may consider another type of interaction, which is polynomials. I'll explain that in a minute. So let's say that we're interested in wage and we're interested in education. Okay, but what if, looking at this graph, what if this looks like it could be that these lower levels of education may not affect your income as much as these higher levels. Okay, so maybe we should use a polynomial. Okay, so specifically, we'll use education and education squared. Okay, now the reason I said before that maybe this is kind of like an interaction is because, well, if we just break that squared out, it actually looks just like the interactions above, right? So we've got our coefficient, we've got one term, we got another term that we're multiplying. So this actually looks a lot like the interactions, and in fact, how we're going to interpret this through finding what's called the marginal effect on this page, that's actually going to be very similar. All right, so The first step is kind of figuring out what the effect of these things are whenever we're having some sort of either a polynomial or an interaction. Is we need to find what's called the marginal effect. Okay, so normally what we would do, let's say the equation ends right here. Okay, so we've just got this simple linear regression of education on wage. Then what we did at that time was we took the derivative of this thing with respect to education. Okay, if we did that, what we'd come out with was beta 1. So we'd say the effect of education on wage is beta 1. Okay, now we just got a bit more of a complicated model, but our approach is going to be the same. Okay, so let's take the derivative of wage with respect to, in this particular case, our variable interest is female. Okay, so let's take the derivative of this whole thing with respect to female. Okay, so let's do this one step at a time. Okay, so what's the derivative of beta 0 with respect to female? That's 0. Okay, there's no female term in that. Well, it's the effect of beta 1 times education with respect to female. Again, it's nothing. What about beta 2 times female? Well, that's got a female in it, so we're just going to take the derivative of that, and that's just going to be our beta 2. What about this term, beta 3 times children? Again, it's nothing. And what about this term, beta 4 times female times children? Now that has female in it. So we take the derivative of that, and that's going to be beta 4 times children. Okay, so the effect of female on wage is beta 2 plus beta 4 times number of children they have. So in other words, the effect of being a female on wage changes based on the number of children. Okay, you know, in real life, what we could do to kind of test this, we could see if this beta 4, if that beta 4 was statistically equal to 0, then we could say, no, there's no difference between males and females when it comes to the effect of children. You know, they're going to be the same. But if there is some beta 4 here, then we know that there is something to that. So, how do we get an exact number? Well, when we run the regression, we're going to get a number for beta 2. We're going to get a number for beta 4. But what about children? Well, we could just add in some numbers that we may find interesting. We might say, well, beta 2 is if they have no children. What about the mean or the median children? Maybe we could put that number in. Okay, so using some interesting numbers, we might be able to learn something new and interesting. So now, if we were to do the same thing with these polynomials, it's just going to be the same approach, right? So let's take the derivative of this whole thing. We're looking at wage here. So let's take a derivative of this whole thing with respect to education. Okay, so this bit here, what's the derivative of beta 0 with respect to education? It's nothing. There's no education term in there. What about this bit? Derivative of beta 1 times education with respect to education. Now that's going to be beta 1. Okay, so let's write this out. So d wage over d education. That's going to be equal to beta 1. And then let's do this part. So what's the derivative of beta 2 times education squared with respect to education? Well, that does have an education term in it. So we're going to bring this 2 down to the front. Oops, wrong term to put that on. Plus, we're going to bring the 2 down to the front times education. Oops. Times education. Hit a pin there. Times education. And then we're just going to subtract 1 from that the exponent there. So we're going to say that's education to the 1, or just education, right? So what we're saying here is the effect of education on wage is beta 1 plus 2 times beta 2. There should be a beta 2 in there. It's right here. Beta 2 times education. Now, in other words, that we're saying that the effect of education on wage depends on the amount of education. And we kind of saw that with this graph we saw here. We saw that At these little bits, these earlier levels, education was having a small effect, but at these higher levels, we're seeing these bigger jumps. Okay, so how much education you have might determine the effect. Okay, again, just like we saw with this one, what education values we use, it really depends on the questions we're trying to ask. A lot of times we'll use, again, the median or the mean in order to find out what sort of effects education has on wage on average. But in this particular case, we might be interested in this fact. Then, well, what's the effect for these people that have a lot of education? What's the effect down here? So we might be interested in asking those questions. Okay. All right, so that is pretty much it. So sorry again about the first time that there wasn't any sound on this, but hopefully you get this one, and let me know if you have any questions. Feel free to show up at the office hours. Don't forget the midterm is tomorrow. That's Thursday, so today by the time some of you will be watching this. So thank you very much.